In this video, we are going to solve another system of nonlinear equations. We have ourselves a linear equation with a quadratic equation. So, kind of your potential options, I suppose, are you have a parabola. It could cross through twice. It could kind of just graze it, or it could not hit it at all. So we're going to probably get something like either two solutions, one solution, or no solution on something like this. Now you could graph it, but the limitation to that is if it does cross twice, does it mean it's going to cross at nice spots where I could just grab coordinates right from the graph? Maybe, maybe not. So I'm just going to jump into the algebra of this and then maybe kind of verify it with the graph if we need to. So, and again, substitution and elimination are my options. Substitution or elimination is not going to work real well because I don't know how to cancel away an x squared with, you don't have an x squared on the other equation. So substitution is what we can do. So with substitution, we already have a y equals already sitting there. So I can take that y equals and I can substitute it into the y on the top equation. So if I do that, I'd have x plus 3 minus x squared, because that was y, and that equals 5. Well, I have a quadratic. So I want to go about solving this quadratic. I don't like that I have a negative x squared, so I'm going to take all of those pieces and bump them over to the other side. So I'm going to add the x squared, I'm going to subtract the 3, and I'm going to subtract the x. So I'll subtract the 3 with those two, and then otherwise I'm just going to be adding x squared and subtracting x. So that's going to get me an x squared minus an x plus 2 equaling 0. All right, so now I need to solve that. The bad news is it's not factorable because there's nothing that multiplies to a positive 2 that's going to add to a negative 1. So here we go. That means we're going to use quadratic formula to solve this thing. So x is going to equal a negative 1, so 1 plus or minus square root of negative 1 squared minus 4 times a times c, all divided by 2 times 1. So if we do the math on the inside, this is going to be a 1 minus 8, so it's going to be 1 plus or minus the square root of negative 7 divided by 2. Well, that creates an imaginary, and we're not going to have imaginaries or anything like that, so this is leading me to believe that we have no solution. So we should be looking at lines that are not crossing each other. So let me jump into the graph real quick to validate that this parabola and this linear are not going to cross each other at all. So it's going to be they're somewhere off away from each other. So the parabola. The parabola, if I kind of rewrite that thing, I'm looking at a y equals a negative x squared plus 3. So this is a parabola that's going down, but it's bumped up 3. So I'll go 1, 2, 3, and the graph on a parabola is we are going, instead of, there's two different ways to do it. One of them is you kind of go out and then square that value, and you'll go up however far that is. So if you went out 2 and squared it, you go up 4. But the negative is going to reflect everything. So we're going to go out 1, square it, and it's going to force us to go down. If we go out 2 and square it, that's 4, so we'll go down 4. And if I go out 3 and square it, I'll go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's probably plenty. And then it's parabola, so it's reflected onto the other side as well. All right, so there's our parabola. All right, and then we have our linear, which is not quite ready to graph, so let me manipulate that just by bumping the x over. So y is going to equal a negative x plus 5. So y-intercept of 5, so that's 3, 4, 5. And then it's a down 1 over 1. So they are not going to cross each other. So we do not have a solution on that for sure. So that was our second example of systems of nonlinear equations, and then we'll do 2 others.